today we are reviewing first. Okay, this front page is all review from 9th grade. We're going to review how to add and subtract polynomials. Now, the copies are kind of light, so I'm just going to kind of go over the signs so that we don't make a mistake. Alright, when you see a problem like that, what's the first thing that you need to bring your attention to? That it's subtraction. Good. Since it's subtraction, what do we have to do? Right. The subtraction sign does not just belong to that 2. It belongs to everything in parentheses. It belongs to the 2 and to the 5x squared. So you're basically distributing that minus to everything after it. Now, that does not do anything to this first binomial. It stays x squared plus 1. But for this binomial, it becomes minus 2 minus 5x squared. And really, I didn't mean to. At this point, once you've distributed, you really do not have to continue writing the parentheses. Okay, now at this point, you're just ready to combine like terms. This x squared, isn't that a 1x squared? What can it combine with? The negative 5x squared. Okay, well, what is 1 minus 5? Negative 4x squared. Then once you've dealt with the x squared terms and combined them, I always mark them out. That way I don't get confused. Like they don't get in the way. Because now that I've marked them out, I basically see all I'm left with is a 1 minus 2, which is negative 1. Okay, now, the directions on this page don't ask you to do this, but I'm going to add some directions because we need to. Remember the first lesson we learned of this unit, how to name polynomials by their degree and number of terms? We need to go over that because I'm pretty sure most of you have forgotten it. Okay, what is the highest exponent in that answer? 2. So what do we call it when it's degree 2? Quadratic. Good. That's his first name. Its last name is determined by how many terms it has. How many terms are in that answer? 2. 1, 2, and so that makes it a binomial. So its full name would be a quadratic binomial. Quadratic because it's degree 2. 2 is the highest exponent. Binomial because it's 2 terms. Okay, so I want you to do that for each of these because we need to practice that to get ready for next Friday's test. Yes. This is basically all review leading up to what we're going to learn today. All right, number 3. We have a 3a squared minus, what does that say? 7a to the 4th plus 3a to the 4th minus 2a squared. Okay, what's the middle sign? What are they doing to these polynomials? Adding them. So do we have to worry about distributing that? No, you only have to worry about distributing it when it's subtraction. Now we're ready to combine like terms. Now, normally I would just start from left to right. But this morning, my co-teacher suggested a good idea. Aren't we going to want to put this in standard form at the end? Yeah. So why don't we just do it in standard form as we go? Why don't we start with this one since that's the largest exponent of the problem? And what can it be combined with? The 3a to the 4th. So what is a negative 7 plus 3? Negative 4a to the 4th. Okay, so now we have combined the a to the 4th terms. And now we have 3a squared plus negative 2a squared, which is positive 1a squared, and you don't have to write that 1. And see, when you do it that way, picking the ones first that are the highest exponent, you end up with it in standard form, and you don't have to take the step to rearrange it. Okay, so now that we have our polynomial in standard form, what is the highest exponent in that answer? 4. Does anybody remember the special name for a degree 4? Quartic. Good. And then how many terms does that have? 2, so it's a binomial. Right. Y'all are remembering this better than some of the classes. Okay, number 5. We have 3p to the 4th minus 5p cubed plus 5p to the 5th plus 4p to the 5th plus 4p to the 4th plus 7p cubed. All right, do we need to distribute that middle term or that middle sign? No. So we're ready to combine like terms. But if we want them in standard form, we might as well start with the exponent that's the largest. In that case, that would be the, right, here's a 5. So we need to start with that 5p to the 5th, and it can be combined with, right, and since we're adding, 5 plus 4 is 9p to the 5th. Okay, so the p to the 5th terms have been combined. Okay, next we move to what term?
4.
This 3p to the 4th and this 4p to the 4th, both are positive, and when you add them together you get 7p to the 4th. Okay, then we move to what term next? The cube terms. We have a negative 5p cubed and a 7p cubed. When you add negative 5 plus 7, you get positive 2p cubed. Okay, so now we've combined all terms together that can be combined. What is the name of this? Quintic. Degree 5, which is when 5 is the largest exponent, is quintic. And then what kind of trinomial? Because it has 3 terms. Okay, number 7. Alright, the middle sign is addition, so there's no need to distribute. We're ready to combine like terms. Which one do we start with? The negative 5m cubed, and it can be combined with, and that's a 1m cubed, right? So what is negative 5 plus 1? Negative 4m cubed. Okay, then what term do we move to next? Right, we have 3m squared plus negative 3m squared. 0m squared. So do we have to write that? No. Okay, and then you see that all we're left with is a negative 4 plus a negative 1. Okay, so what is the name of that polynomial? Cubic, because it's degree 3. The highest exponent is 3. What kind of cubic what? Binomial, because it's 2 terms. Okay, number 9. Is there any need to distribute the middle sign? No, because it's positive. So we're ready to combine like terms. What term over here do we start with? This one to the 5th, and it can be combined with this one, but like Eric said, this one's a negative 3. When you add it to a positive 3, they cancel to 0, so there's no need to write 0x to the 5th. Then we move on to what? The cube terms. 7x cubed and 2x cubed added together make 9x cubed. Okay, then we move on to the squared terms, and that's 3 plus a negative 1, which is 2x squared. And then that leaves us with what? Okay, what's negative 7 plus negative 3? Negative 10x. Okay, what's the name of this polynomial? Right, cubic trinomial. Okay, number 10. Once again, we're adding, so we don't have to worry about distributing that sign to the rest of it. We're ready to combine like terms. Which term over here do we start with? Okay, and we can combine it with what over here to make a total, how many m to the 5th? 14m to the 5th. Okay? Then we move on to, right, and what does it combine with? So what do we do with it? Just bring it down. Okay, then what do we go to? And, okay, and add it together, that makes how many m cubed? 9m cubed. Okay, and then we go to, okay, what's negative 3 plus negative 2? Right? And then now that I've scratched everything out, what's left? Just that plus 1. Okay, so what do we name this polynomial? Quintic, because it's degree 5. It has 1, 2, 3, 4, 5 terms. So do we know a special name for that kind? So we just say polynomial with 5 terms. No, the degree has to do with the exponent, and that's why we call it quintic. Okay, now I'm going to give you a few minutes, and I want you to try 11 and 12, and then on the other side, 2, 4, 6, and 8. Number 11, what did y'all get? Yeah, the answer, like this part. Right? Is that what everybody got? Okay, so what kind of polynomial is that? Right, quartic polynomial with 4 terms. Okay, what about number 12? What did y'all get? Right, is that what everybody got? Okay, what do we name that one? Right. Okay, now up to number 2. Okay, number 2, y'all got 3x squared. Okay, so what is that one called? Well, what is the highest exponent? 2, so that's quadratic. And then it's a monomial because it's 1 term. Then, like the next one, we're about to get to one. What's the answer for number 4? Okay, see how this k doesn't have a visible exponent? That's an understood 1. Whenever your highest exponent is a 1, it's linear. And think about it. When you're graphing lines, aren't they in the form mx plus b? Mx plus b. Okay, and then what linear what? Binomial, because it's 2 terms. All right, number 6. What'd you get for number 6? Oh, yeah, hold on. Hold on 1 second. Okay, 6m cubed. Okay. Is that what y'all got? Okay, then what kind of polynomial is it? Cubic, because the highest exponent is 3. Trinomial, because it's 3 terms. Okay, and then number 8. Right, and then what do you name that one? Right, quintic polynomial with 4 terms. Okay, before we move on to the back, we're going to use our devices real quick. Turn them on. It's not. Okay, shh, pay attention, guys. All right, now we're going to add and subtract complex numbers. See how these have i's, the imaginary number, right next to a real number? They're called complex numbers. When you are adding and subtracting complex numbers, you're going to write it in the form with the constant first and then the complex number second. So we're going to, for these, add the constants first. So let me go through and darken these signs. That's a negative, positive, positive, negative, and this is a negative. Okay, so what are the 2 constants in that problem? -6 and -10, right? Now, when we combine those by adding them, what do you get? -16. Okay, so now we're done with the constants. We combine them and they made -16. Now we're going to combine these complex numbers. We have 6i plus -6i. If you have 6 i's and somebody takes away all 6, 0. So we're done. That's the final answer. Okay, number 3. No, not yet. When we get into I squares. tomorrow when we start multiplying these and we have I times I, that will make an I squared, and an I squared equals -1. But when adding and subtracting, it's really no different than what we just did on the last page. It's just instead of an X, we have an I. Okay, number 3. We have a -9 plus 8I plus -4 plus 6I. So first we're going to combine those constants, which are what and what? Okay, when you add -9 plus -4, you get okay, so we're done combining the constants. Now we're going to combine the complex numbers, which are what and what? So we have 8I plus 6I, which is positive 14I. And then that's the answer. Yep. Okay, so now let's look at number 5.
Oh, God.
It's really not hard. They just make it look complicated by adding in these extra sets of parentheses. Doesn't this minus belong to that 2 and this minus belongs to that 2I?
Yes.
And then since this is a plus, it's not going to distribute to each of those. That's just going to say -8 plus 9I. So first let's combine the constants. We have a -2 plus a -8, -10. Then we have our complex numbers, which is a -2I plus 9I. Positive 7I, right. And that's the final answer. I mean, it does if there's more than one thing in there. Like you would combine what's in the parentheses first. But there was only, really for this, there's no need for those parentheses. They're just there to confuse you. Because there's only one thing in there. There's no need for them. Now, like if this were squared or something on the outside, there would be a need. But there is no need for those parentheses. Okay, so now let's look at number 7. Both of these are in parentheses, but there's nothing on the outside, so really there's no need for them. And then this is a -4I. There's really no need for those parentheses. So just kind of ignore them. You have a 2 minus 10, which is -8. And then you have a -7I minus 4I, which is -11I. Okay, so really what we're doing here is no different than what we just did on the previous page. Even though they are complex numbers, adding and subtracting them doesn't really, there's nothing different. Okay, number 9. Here's where we're going to have to do something a little different. And what am I talking about? Right, there's a minus sign in the middle, and since there's 2 things after it in the same set of parentheses, both of those get that negative sign. So now this becomes -6 minus 11I minus 12 minus 11I. Does that make sense? Okay, so now let's start with the constants. We have a -6 minus 12, which is -18. And then we have a -11I minus 11I, -22I. Remember, to get 0, it would have had to have been -11 plus 11. Okay, let's do one more together. We have parentheses, but do they really matter? No, because there's a plus in between them. So now let's start with the constants. We have a -6 plus -8, -14. And then we have a, is that a positive 12I plus -2I? Positive 10I. Okay, your homework is to finish the odd problems on this page. So 13, 15, 17, 19, 21, and 23. It is 1:52. We have 8 minutes. Okay, so you could probably finish all of those in the next 8 minutes. Once you're finished, or once you've finished half of them at least, you can switch out.